In this chapter, students will interpret multiplication as scaling, as well as solve real-world problems involving multiplication of fractions and mixed numbers. In previous lessons, students have learned that the division of whole numbers can be thought of as fair sharing. For example, 15 divided by 3 is 15 things partitioned into 3 equal parts, which equals 5. 5 is the size of one share. Students have learned how to multiply a whole number by a fraction in 4th grade. For example, 2/3 of 6 is 12/3, or 4. As students work to interpret fractions and multiply fractions, they will make connections to whole number operations. In the first couple lessons in this chapter, students will reason that A divided by B equals A over B. A over B is the size of one part or one share when A is partitioned into B equal parts. This means a fraction can be viewed as the quotient of the numerator divided by the denominator. For example, 3/4 equals 3 divided by 4. 3/4 is the size of one share when 3 is partitioned into 4 equal parts. Students will then be asked to create a story context to represent the problem. Let's use 3 divided by 4 to create a story. If 4 people share 3 of the same size candy bars equally, how much of one candy bar does each person receive? Students will solve this problem multiple ways. Let's look at just one way. Students may solve by partitioning each candy bar into 4 sections, so that each person gets 1/4 of each of the 3 candy bars, for a total of 3/4 of one candy bar. This will then lead students to reason that 1/3 times 5, which is 5/3, is one share when 5 things are shared evenly among 3. They will then extend onto the idea to see that 2/3 times 5, which is 10/3, is 2 shares when 5 things are shared evenly among 3. Notice that 10/3 is twice as much as 5/3 because it is 2 shares. By understanding these concepts, students can answer the questions, how much is one share, and what part of the whole is one share, without performing any calculations. It is important to keep answers in original form without simplifying to recognize these concepts. In this chapter, students are challenged to reason about the size of the product relative to the size of the factors. They will recognize that when one factor is less than 1, the product will be less than the other factor. For example, 1/7 times 35 equals 5. They will also recognize that when one factor is greater than 1, the product will be greater than the other factor. For example, 3/2 times 4 equals 12/2, which equals 6, and 6 is greater than 4. Students will also recognize that 4/4 is equivalent to 1 and use the identity property of multiplication in solving problems. For example, 5 times 4/4 is the same as 5 times 1, which equals 5. In previous chapter prefaces, fractions as operations for multiplication and division were described. Another way students view fractions in 5th grade is as an operator. An operator indicates that an operation should be used, and in the case of fractions, multiplication and division are combined. For example, what is 3/4 of 8 cups of sugar? Students could divide by 4, then multiply by 3, as seen here. The model shows 8 units partitioned or divided into 4 equal parts, which equals 2 units. The 2 units are then multiplied by the numerator, 3, for a final answer of 6 units. 3/4 of 8 is 6. Students could also multiply by the numerator first, then divide by the denominator. Start by drawing the 8 units, or 8 cups, then multiply by 3 to get 24. Next, divide the 24 units into 4 groups for a total of 6 in each group. 3/4 of 8 is 6. Finally, students will build on their knowledge of fractions multiplied by whole numbers and extend it to fractions multiplied by fractions. Students will also use reasoning about multiplying whole number by a whole number to explain these new aspects of fraction multiplication. Let's look at 2/3 times 4/5. Start by showing 4/5 on a number line. Next, divide 4/5 into 3 equal parts. Then take 2 of those parts for a total of 8/15. This shows the length of 2 parts when 4/5 is divided into 3 equal parts. This will then lead students to make the generalization that any two given fractions, a over b times c over d, where b and d are non-zero whole numbers, equals the length of a parts when c over d is divided into b equal parts. In this chapter, students will interpret multiplication as scaling, as well as solve real-world problems involving multiplication of fractions and mixed numbers. Students should be given ample time to discuss and discover as they work with the fractions in this chapter to solidify their understanding of fractions. Students should also be able to visually represent their ideas to prove their thinking. By giving students time to do this, it will support them in their development of fluency with fraction computation.